Hello there, space enthusiasts. It's great to be back with another video exploring the wonders of the universe. Back in the 1970s, scientists studying the afterglow of the Big Bang, known as the cosmic microwave background, stumbled upon something truly mind-blowing. Our galaxy, and everything in it, including you, is hurtling through space at an astounding speed of 50 kilometers per second. To put that in perspective, at that velocity, you could travel from Earth to the Moon and back in just 11 minutes. Seriously, that's so fast it kind of freaked out the scientists. At the time, no one really knew where the Milky Way was rushing off to with such urgency. A large portion of that 583 kilometers per second can be attributed to the expansion of the universe. Imagine the universe as a balloon and the galaxies as little dots or drawings on that balloon. As the balloon inflates, the drawings move further apart, even though they themselves aren't actually doing anything. This is what we call the Hubble flow. Another factor influencing the Milky Way's movement is the literal gravitational attraction of our galactic neighbor, the Andromeda Galaxy. We're currently speeding toward Andromeda, perhaps hoping to hang out and maybe do some cosmic bonding at a rate of about 110 kilometers per second. But when scientists crunched the numbers, these factors still didn't account for the full 583 kilometers per second. Something was still missing. Clearly, we were moving way faster than we should be. Faster than even our best scientific minds could explain. It turns out that our entire galaxy is being pulled away from the uniform expansion of the universe towards some mysterious, unseen object lurking in the distance. And it's not just the Milky Way. Every galaxy within a cosmic neighborhood spanning roughly 500 million light-years, encompassing around 100,000 galaxies, is also being inexorably drawn toward this same colossal, unidentified entity. It's honestly a little terrifying if you really stop and think about it. Applying their astronomical artistry, scientists have dubbed this enigmatic object the Great Attractor. Sounds cool, right? But the big question is, what exactly is the Great Attractor? When you seriously consider something capable of pulling an entire galaxy off course by hundreds of millions of light-years, what could it be? Some kind of cosmic love at first sight? What? Am I crazy? Well, in a way, it's kind of like that old saying about how love can make you climb any mountain or cross any ocean, except in this case, it's hundreds of millions of light-years. But all kidding aside, gravity is the universe's version of love. Everything with mass has gravity, and gravity is a form of attraction. The more mass, the stronger the gravitational pull. That's the basic principle. But to attract 100,000 galaxies, a number that would take you like 40 hours just to count, from distances of hundreds of millions of light-years, the attraction would have to be immense. And when I say immense, I mean super mega ultra ultimate Saiyan super level 100 immense. So what could possibly create such a tremendous gravitational pull? And more importantly, what will happen when we get pulled into it? There's a saying that when you have two questions, you should always answer the first one first. It's no coincidence that the question of what the Great Attractor actually is has been stumping scientists for, well, a really long time. When astronomers pointed their telescopes in the direction they believed the Great Attractor to be, all they saw was, well, nothing. If this universe were a simulation, it would be as if the programmers deliberately obscured the Great Attractor. And if it were created by God, well, maybe God is a bit of a messy housekeeper, leaving behind a whole lot of cosmic clutter after creating the Milky Way. Sure, he created this beautiful spiral galaxy, about 100,000 light-years across and 1,000 light-years thick, and sprinkled it with 100 billion stars. But he apparently forgot to clean up the interstellar dust and gas clouds, which obstruct our view when we try to peer through the galactic plane. The portion of the night sky obscured by the Milky Way's plane is known as the zone of avoidance, and it blocks about 20% of the extragalactic sky when observed using visible light, the light you can actually see. And, coincidentally, the Great Attractor lies smack dab in the middle of the zone of avoidance. Probably not on purpose, right? That's why, for decades after its discovery, the Great Attractor remained a cosmic blind spot, its true nature only a matter of speculation. It wasn't until the 1990s, by measuring its gravitational influence on surrounding galaxies, that scientists began to piece together the first clues about what it might be. Something potentially big, dark, and not very pretty. It turns out that the Great Attractor is located between 150 and 250 million light-years away in the direction of the Norma constellation. And according to the best estimates, its mass is equivalent to 10 million billion suns. Wow. At the time, that number, 10 million billion solar masses, wasn't just big. It was mind-bogglingly enormous. One of the first things that popped into scientists' heads when they needed a mysterious, supermassive object with an incredible gravitational pull was, of course, a black hole. But even the largest supermassive black holes known to the world at the end of the 20th century, like TON 618, were far too lightweight to be a contender. TON 618 is one of the biggest, heaviest, and brightest single objects ever discovered. It boasts a diameter of up to 780 billion kilometers, which is 2,600 times the distance between the Earth and the Sun. To put it another way, if you could travel at the speed of light, it would still take you a whole month to zip from one side of it to the other. The supermassive black hole in TON 618 powers a quasar that shines with the luminosity of 140 trillion suns. These numbers are so absurd that someone hearing them for the first time might think, oh, come on, that's gotta be fake news. And yet, even with these seemingly made-up stats, TON 618 only weighs in at 66 billion solar masses. Still an incredibly scary thing, and truly a cosmic nightmare for any civilization. But still about 150,000 times smaller than the bizarre object scientists were searching for. And even if you brought the Phoenix, a black hole, the undisputed king of black holes, with its mass of 100 billion suns, to the party, this cosmic monster still wouldn't even make a dent. But if even the largest single object we know of doesn't even come close to matching the Great Attractor, then what is it? A morbidly obese black hole? A multi-galactic superstructure built by a Type 4 civilization? Or maybe just the secret hiding place of 673,000 ancient alien artifacts? Breakthroughs in astronomical technology, including telescopes using radio waves and infrared light, have allowed humans to peer through the thick dust clouds, glimpse the zone of avoidance, and get a clearer view of the mysterious 10 million billion solar mass entity lurking behind it. But what we saw, and trust me, I wish I could make up something super scary and haunting, but it turned out to be just a whole lot of galaxies. While it may not be the most thrilling discovery, figuring out the true nature of the Great Attractor did help clarify some things. We used to think of the universe as a collection of 200 billion galaxies scattered completely randomly, but that's not really the case. In reality, if you could step outside the universe and look back in, you'd see a vast structure that scientists call the cosmic web. The theory suggests that the early universe was a bit like a poorly mixed bowl of batter, with some parts thicker and some parts thinner. The denser regions, with more mass, had a stronger gravitational pull and began attracting even more matter. Over billions of years, the rich regions of the universe became richer, and the poor regions, poor in terms of matter that is, became poorer. Sounds a bit like capitalism, doesn't it? In this way, gravity, that weak but infinitely reaching force, shaped the universe, drawing billions of galaxies together to build superstructures of epic proportions, while simultaneously creating vast, empty voids. And gravity is a very hierarchical architect. In any direction of the universe, we point our telescopes, everything is clearly organized. Our Sun, for example, is one of hundreds of billions of stars in the Milky Way galaxy. The Milky Way is one of about 80 galaxies and dwarf galaxies that make up what's known as the local group. The local group is one of approximately 100 groups and clusters of galaxies that make up the gigantic Virgo supercluster. In the past, when the zone of avoidance was still a blind spot, we thought the Virgo supercluster was the most tremendous structure in our corner of the universe. But since we've been able to see through it, the truth has been revealed. What we thought was gigantic is beyond the comprehension of our biological brains. The Virgo supercluster, containing approximately 45,000 individual galaxies, is just one branch of an even larger structure, the Laniakea supercluster. The Laniakea supercluster is unbelievably vast, and sadly, I'm not nearly eloquent enough to adequately describe how mind-bogglingly enormous it is. But statistically speaking, this supercluster is approximately 520 million light-years across, big enough to line up 5,200 Milky Ways from one end to the other, and currently the home address of at least 100,000 galaxies. And what we call the Great Attractor is located somewhere in the middle of this supercluster. Or, rather, the Great Attractor isn't in the Laniakea supercluster. It is the Laniakea supercluster. Einstein taught us that space-time is like a giant, flexible fabric. Put a heavy object on it, and the fabric dips down. Lighter objects then follow the curve toward the heavier object. The greater the mass, the deeper the dip, and the stronger the gravitational pull. In this sense, the Great Attractor is simply the deepest point in that flexible fabric in our corner of the universe. Pulled down by the immense mass of the Laniakea supercluster, dragging all the surrounding galaxies from hundreds of millions of light-years away toward it. Sounds pretty scary, doesn't it? So what will happen when we get there? Well, if you're in a hurry, you can relax, because we're never going to get there. The Great Attractor is approximately 200 million light-years away. At our current speed, it would take us more than 100 billion years to reach it. Ignoring the fact that we will all have shuffled off this mortal coil long before then, we are never, and I mean never, going to get there, even if we were immortal. The reason is the expansion of the universe. We may be hurtling toward the center of the Laniakea supercluster at breakneck speed, yes, but space-time, that flexible fabric of the universe, is expanding at an even faster pace. Furthermore, it's expanding at an accelerating rate that increases with distance. In other words, the farther away something is, the faster it's receding from us. And, even crazier, the expansion rate of the fabric of the universe isn't limited by the speed of light, while our speed through space-time is limited to, at most, just below the speed of light. In other words, even if the Milky Way strapped rockets to its rear end and blasted toward the Great Attractor, after billions of years, our destination would still be getting farther and farther away. If you find this hard to understand, imagine two ants crawling on a balloon. If the balloon isn't being inflated, the two ants will eventually meet. What they'll do when they meet, I have no idea. But if you start blowing up the balloon, and if your lungs are strong enough, the ants will get farther and farther apart, no matter how hard they try. I don't know if that's good news or bad news. What do you guys think about all of this? Feel free to leave a comment below. As always, remember to like and share if you found this video mind-bending. Subscribe to our channel and hit the bell icon for even more mind-blowing content. And now, goodbye, and see you next time. It's one of the most terrifying entities in the universe. a nightmare for any civilization. Yet it's still roughly 150,000 times smaller than the monstrous object scientists are searching for. And even if you brought the reigning black hole champion, Phoenix A, to the party, this cosmic behemoth with 100 billion solar masses wouldn't even cause the big attractor to budge an inch. But if the largest known single object isn't even a fraction of the Great Attractor, then what is it? Is it an absurdly obese black hole? A multi-galactic superstructure constructed by a Type 4 civilization? Or perhaps the hiding place of some 673,000 provinces? Fortunately, advancements in astronomical technology, including radio and infrared telescopes, have allowed us to peer through dense dust clouds, vaguely glimpsing the Botes void and the mysterious entity, weighing 10 million trillion suns, lurking behind it. However, what we're seeing, and believe me, Vyacheslav would love to fabricate something incredibly terrifying and haunting, is unfortunately just galaxies. A vast multitude of galaxies. While that might not sound as thrilling, discovering the true nature of the Great Attractor does clarify some things. For a long time, we thought the universe was a collection of 200 trillion galaxies, scattered completely randomly. But that's not really the case. In reality, if you could stand outside the universe and look in, you'd see a gigantic structure that scientists call the cosmic web. The hypothesis suggests that the early universe was like a poorly mixed bowl of porridge, with some parts thick and others thin. The denser regions, possessing more mass and therefore stronger gravity, began to attract more matter. Over billions of years, the rich regions of the universe became richer, and the poor regions, materially poor that is, became even poorer. Sounds a bit like capitalism, doesn't it? In this way, gravity, that weak but infinitely far-reaching force, has shaped the universe, pulling billions of galaxies together to construct mind-boggling superstructures. But it has also created extraordinarily empty regions. And gravity is a remarkably meticulous architect. No matter where we point our telescopes in the universe, everything is organized in a clear hierarchy. The Sun, our star, is one of hundreds of billions of stars in the Milky Way galaxy. The Milky Way is part of a neighborhood of about 80 galaxies and dwarf galaxies, collectively known as the Local Group. The Local Group is one of about 100 groups and clusters of galaxies that form the enormous Virgo supercluster. In the past, when the Boötes void was still a blind spot, we thought the Virgo supercluster was the most formidable structure in our corner of the universe. But since our vision has cleared, the truth has been revealed. What we once called gigantic is beyond the comprehension of the biological brain. The Virgo supercluster, containing about 45,000 individual galaxies, is just one branch of an even larger structure, the Laniakea supercluster. The Laniakea supercluster is unbelievably vast. And sadly, I'm not eloquent enough to describe to you just how insane it is. But statistically speaking, this supercluster is about 520 million light-years across, enough to line up 5,200 Milky Ways from end to end. And it's currently the home address of at least 100,000 galaxies. And what we call the Great Attractor is located somewhere within this supercluster. Well, not quite. The Great Attractor isn't located in the Laniakea supercluster. It is the Laniakea supercluster. Einstein enlightened us that space-time is like a giant, stretchy fabric. Place a heavy object on it, and the fabric sinks. Lighter objects then fall along the slope toward the heavier object. The greater the mass, the deeper the depression, and the stronger the gravitational pull. In this understanding, the Great Attractor is simply the deepest point in the fabric of space-time in our corner of the universe. It's depressed by the immense mass of the Laniakea supercluster, pulling all the surrounding galaxies from hundreds of millions of light-years away towards it. Sounds pretty terrifying, doesn't it? So, what would happen if we got there? Well, if you're in a hurry, don't worry, because we're never going to get there. The Great Attractor is about 200 million light-years away from us. At our current speed, it would take over 100 billion years to reach it. Even if we ignore the fact that we'd all be long gone by then, we're never, and I emphasize never, going to get there, even if we were immortal. The reason is the expansion of the universe. We might be hurtling towards the center of the Laniakea supercluster at a dizzying speed. True. However, space-time, the stretchy fabric of the universe, is expanding at an even more dizzying rate. Furthermore, it expands at a rate that increases with distance. That is, the farther something is away, the faster it's receding from us. What's even wilder is that the expansion rate of the fabric of the universe isn't limited by the speed of light. But our speed of movement on the fabric of the universe, even at its fastest, is only close to the speed of light. In other words, even if the Milky Way strapped rockets to its butt and blasted towards the Great Attractor, after billions of years, our destination would still be getting farther and farther away. If you're finding this hard to understand, imagine two ants crawling on a balloon. If the balloon isn't being inflated, the two ants will eventually meet. What they'll do when they meet, I don't know. But if you start blowing up the balloon, and if your lungs are strong enough, the ants will get farther and farther away from each other, no matter how hard they try. I don't know if that's good news or bad news. What do you all think about this? Feel free to leave a comment down below. As always, remember to like and share if you found the video mind-bending. Subscribe to BrainPop Universe and ring the bell for even more mind-bending content. And now, goodbye, and see you next time.